Hello students. Today we will discuss about transformers. So transformer is a third passive uh, inductor or transformer. It is a third passive important passive component. It is a third important passive component transformer. So transformer has two inductors or transformer consists of two inductors or two coils. These coils are also called as windings. So there are two windings, primary winding and secondary winding. So transformer consists of two types of windings, primary winding and secondary winding. Okay. So from this number of turns used in transformer, there are two types of transformers: step up transformer and step down transformer. In step up transformer, the output voltage between the secondary winding, it is larger than primary winding. Yeah, primary is always connected to AC mains supply to 230 volt, and we get a secondary voltage across the secondary winding. Okay, so when if the number of coil turns are larger than number of turns in primary winding, if it is less than secondary winding, that is number of turns in secondary winding is larger than primary winding, then this transformer is called as step up transformer, because since the number of turns in secondary winding is larger than primary winding, we get more voltage than primary voltage. Okay, so input voltage is suppose 230 volt, then secondary voltage will be greater than 230, or it is more than 230 volt. So this type of transformer is called as step up transformer, because the number of turns of secondary winding, it is more than primary winding, therefore it is called as step up transformer. Now in step down transformer, secondary voltage is less than input primary voltage, because secondary winding is very less than primary winding. That is, number of turns in secondary winding, it is very less than number of turns in primary winding. So it is called as step down transformer, because we get less voltage than primary. Suppose the input primary voltage is 230 volt, then here in secondary winding we get 9 volt, 230 to 9 volt, or 230 to 6 volt, or 230 to 12 volt, like this. So this type of transformer is called as step down transformer. Okay. Now there is a turns ratio of a transformer. Turns ratio of transformer means number of turns in primary winding divided by number of turns in secondary winding. This is called as turns ratio of transformer. Turns means the number of turns, or number of turns of copper coil used for primary. This number of turns, yeah, it is called as NP. It is called as NP, means number of turns in primary winding divided by number of turns in secondary winding. So this is called as turns ratio of the transformer. So this turns ratio is always equal to the voltage ratio, that is Vp upon Vs, where Vp means primary voltage and Vs means secondary voltage. Okay, so Np upon Ns is equal to Vp upon Vs. This is the transformer ratio, and that is equal to Is upon Ip, where Is is secondary current divided by primary current. Okay, so this is called as transformer ratio. Okay, so transformer is a device which transfers electrical energy without changing the frequency. It transfers electrical energy from primary to secondary, and this transformer works on the principle of mutual induction. Mutual induction. So this transformer works on the principle of mutual induction, because when when AC current flows through one winding, there is a change in magnetic flux, and due to change in magnetic flux, secondary winding cuts this magnetic flux, and therefore induced voltage is developed across the secondary winding because it is placed near to primary winding. And since the magnetic flux cuts across this secondary winding, so this winding, secondary winding cuts this magnetic flux. It is a changing magnetic flux, and therefore voltage is induced into the secondary. So this is called as mutual induction. So transformer works on the principle of mutual induction, or it is based on Faraday's law of electromagnetic induction. This transformer action or transformer working, it is based on Faraday's law of electromagnetic induction. Where what is Faraday's law? So whenever there is change in magnetic flux, induced EMF is generated, or induced EMF is developed into the second winding. This is called as Faraday's law of electromagnetic induction. Or again, the second definition is the induced voltage is directly proportional to rate of change of magnetic flux, that is d phi by dt. E is equal to d phi by dt. Whenever there is a change in magnetic flux, induced EMF is developed, induced EMF is generated. So this is called as Faraday's law of electromagnetic induction. Okay. So transformer is an important device in which voltage is transferred from one winding to another winding without changing the frequency. Frequency does not change. It is 50 Hz. Okay, 50 Hz. And we get in step down transformer, we get 9 volt, 12 volt, such type of voltages across the secondary. That is 230 volt to 9 volt. Okay, or 230 volt to 12 volt. Okay, these voltages are obtained across secondary. But in a step up transformer, the secondary voltage is greater than primary. For example, 250 volt or 1 kilovolt also. Okay, so we get large voltage across secondary than primary. Primary voltage is 230. So here we get 250 or 1000, okay, or 600, like this. So this voltage, secondary voltage, is more than primary in step up transformer. Okay. Now the transformer working principle. What is the working principle? So when AC current flows, or when AC voltage is applied, to the primary winding, then AC current flows through primary. Okay, AC current flows through primary, and therefore there is a change in magnetic flux produced, which will this magnetic flux cuts to the secondary winding, and since the secondary winding is kept close to primary winding, therefore this winding cuts this magnetic flux. It is a change in magnetic flux, and therefore voltage is induced into the secondary winding. According to Faraday's law, voltage is induced into the secondary winding. Now the amount of this induced voltage, it depends upon the number of turns of primary winding and number of turns in secondary winding. Okay, so if the number of turns are more, then more voltage is induced into the secondary winding. Okay, but if the number of turns are less, then less voltage will be induced into the secondary winding. Okay, and that is this is called as turns ratio, and this turns ratio is Np upon Ns is equal to Vp upon Vs. This is called as transformer ratio. Okay, here the primary power, it is always equal to the secondary power. Here, if the voltage is greater, then current will be less. If voltage is greater than primary, then current will be less, because here the input power is equal to output power, that is Vp into Ip is equal to Vs into Is, because P is equal to power is equal to V into I. Okay, power is equal to V into I. So primary power means Vp into Ip, that is equal to Vs into Is. Okay, so power in primary is equal to power in secondary. Okay, that is Vp upon Vs is equal to Np upon Ns. Now let us see one example. See one example. A power transformer has 100 turns of primary. A power transformer has a power transformer has a power transformer has 100 turns of primary. That means primary winding is of 100 turns. That means there are 100 turns in primary winding. Primary winding has 100 turns. Okay, 100 turns, and 5 turns of secondary, and 5 turns of secondary, 5 turns of secondary, 5 turns of secondary. Then calculate secondary voltage, calculate secondary voltage if primary voltage is 120 volt. If primary voltage is 120 volt, primary voltage is 120 volt, and frequency of secondary if primary frequency is 50 hertz, that means frequency of AC in primary is 50 hertz, then what is the frequency of secondary current? Okay, what is the frequency of secondary? Okay, so here we have to calculate the secondary voltage. Okay, so we know that the transformer ratio. What is the transformer ratio? Turns ratio is Np upon Ns. Np upon Ns is equal to Vp upon Vs. Np upon Ns is equal to Vp upon Vs. Okay. Now here the power transformer has 100 turns of primary. That means Np is given. So Np is equal to 100 turns. So Np is equal to 100. Np is equal to 100. And Ns is equal to 5. And 5 turns of secondary. 5 turns of secondary means secondary turns are given. Secondary turns are 5 and primary turns are 100. Okay. So Np upon Ns. Then secondary voltage, we have to calculate secondary voltage because primary voltage is given. So primary voltage, that is Vp, is equal to 120 volt. Okay. And we have to calculate Vs, that is secondary voltage. Okay. So 100 upon 5 is equal to 120 divided by Vs. Okay. Now 100 into Vs is equal to 120 into 5. So Vs is equal to 120 into 5 divided by 100. Vs is equal to 120 into 5 divided by 100. Okay. 5 के 5 5 2 10 12 so Vs is equal to 6 volt. Vs is equal to 6 volt. Okay. that is secondary voltage is 6 volt. Okay, now frequency. The frequency does not change. If the primary frequency is 50 Hz, then in secondary the frequency is also 50 Hz. So frequency does not change. Okay. Now we have to calculate transformer efficiency. So what is transformer efficiency? So transformer efficiency is the output power divided by input power into 100. Output power percentage efficiency is equal to output power divided by input power into 100. What is output power? Output power means secondary voltage into secondary current, that is Vs into Is. And what is input power? Primary voltage into primary current, that is Vp into Ip. So Vs into Is divided by Vp into Ip and into 100. It is called as percentage efficiency. Okay, and this efficiency of transformer, it is always less than 100%. It is less than 100% due to losses in transformer. There are many losses in transformer. So this efficiency is always less than 100%. Okay. Now we will study types of transformers. Types of transformers. Types of transformers. There are different types of transformers. So first is a power transformer. First is power transformer. So power transformer is also called as mains transformer. These transformers have two types of windings, primary winding and secondary windings, and these secondary windings provides various operating voltages. Okay, it provides, secondary winding gives various voltages. Then second type is, and these transformers are used in many electronic equipments. Okay, these power transformers are used in many electronic equipment. Then next, audio frequency transformer. Audio frequency transformer means it is used in audio amplifiers. These audio transformers are used in audio amplifiers. For example, in push-pull amplifier stage, the output transformer, it is audio transformer. Also in for coupling the two stages of audio amplifiers. So middle transformer, this transformer is also audio transformer. This transformer couples the audio signal from one stage to another stage. That is output of first stage, output signal of first stage, it is coupled to the input of second audio amplifier. So this audio transformer couples the signal. It is called as a driver transformer. Okay, this is also audio transformer. So such type of audio transformers are used in audio amplifiers. Audio amplifiers. So audio frequency transformer, it is made to operate audio frequencies at the range of 20 Hz to 20 kHz. They are similar to the power transformers but differ in the core material. And they are used to couple one stage to another stage. So AF transformers, AF means audio frequency. So AF transformers are used in audio amplifiers for interstage signal coupling, for coupling microphone signals also, and for coupling microphone signals to the amplifiers, and for coupling amplifiers to the speakers. Okay, they are available in both types, step up and step down. Okay, in power amplifier stage of radio receiver, step down type audio frequency transformer is used to match the high output impedance of amplifier to the low impedance of speaker. that is to provide maximum power from the amplifier to the speaker. Okay. The next type is a radio frequency transformer. Okay, radio frequency transformer. So radio frequency transformer operates at very high frequencies, and they are generally used with capacitor to form resonant circuit. Okay, because one capacitor is connected across the winding of the transformer, and when in tuning circuit, when capacitor is made variable, then a particular signal is adjusted or captured, okay, from the radio frequency signal of radio station. A particular radio station frequency is captured or tuned due to variable capacitor, because since capacitance can be changed, then frequency also changes. So for tuning purpose or for selecting a particular radio station or for tuning, these RF transformers are used. Okay, so radio frequency transformers operate at very high frequencies. They are generally used with capacitor to form a resonant circuit. Resonant circuit means parallel circuit. Capacitor and inductor are connected in parallel. It is called as resonant circuit. So at higher frequencies, the eddy current becomes effective. To reduce eddy current losses, the RF transformer is made of air core or iron core transformers. Radio frequency transformers are used for interstage coupling, and for coupling signal to and from antenna. Okay, for coupling antenna signal to the input stage of radio frequency amplifier, RF amplifier. Okay, signal coming from the antenna, it is coupled and given to the input stage of RF amplifier. So for coupling the signal from antenna and from amplifier to antenna, these for interstage coupling, these radio frequency transformers are used. Then fourth is intermediate frequency transformer, that is IFT. IFT means intermediate frequency transformer. So intermediate frequency, it lies between audio frequency and radio frequency. It is in between these two frequencies. That is, it is in between. Intermediate frequency is in between audio frequency and radio frequency. So this frequency lies between audio frequency and radio frequency. These transformers are operated at a fixed frequency. These transformers operate at one fixed frequency, that is 455 kilohertz. 455 kilohertz. These transformers operate at the frequency of 455 kilohertz. Okay, so it is called as intermediate frequency transformers. So in radio receivers, a common intermediate frequency is used, and it is 455 kilohertz. They are also used in the intercarrier sound section of television. Okay, these transformers, IFT or intermediate frequency transformers, are used in TV receivers, in sound section of TV receivers, as it is called as intercarrier sound section. Intercarrier sound section of television, and other IF transformers with center frequency at the range of 39 MHz to 48 MHz are used in the video IF section of television receivers. Okay. The next type is auto transformer. In auto transformer, coil is used to provide turns for the frequency for the primary as well as secondary. Okay, so this in auto transformer there is a single coil, and this coil acts primary and also acts as secondary. Okay, so in auto transformer, coil is used to provide turns for primary as well as for secondary. So when whole part of the coil is used for primary, and a small part for secondary, then it is called as step down transformer. And when the entire winding is used as a secondary, it is known as step up transformer. Okay, they are also provided with a fixed or variable taps for different secondary voltages. The next is isolation transformer. Isolation transformer. So when number of turns in primary is made equal to the number of turns in secondary, means number of turns of primary is equal to number of turns of secondary, then such type of transformer is known as isolation transformer. Okay, and it has a 1:1 turns ratio. It reduces the possibility of electric shock. It reduces the possibility of electric shock from the equipment, and it is also used in audio frequency equipment and to block the DC component. To block DC component, this transformer is used, isolation transformer. Okay, so we will stop here.